So you find out you failed your inspection. I'm going to give you a couple of good pointers on some things that are just so simple and that just get on everybody's nerves when they fail an inspection, when it's something so simple as this. And a lot of times it's just some basic stuff that it's a miscommunication between people. Working spaces around electrical equipment on the exterior of a home has always been an issue, and inspectors write this up all the time. They typically refer to the National Electric Code section 110.26a, which requires a 30 by 36 clearance. Now, some may give you a little bit of leeway on that disconnect for the condenser unit, as you see in this photograph, but at the exterior of the building, especially where that main disconnect is located, we need to make sure that we maintain that working space, don't have any equipment set in front of it. And when the fences are installed on the exterior of the building, it's something for the builders to consider. We should not be allowing something so simple as maintaining this clearance to cause a failed final inspection. In the southern United States, I have seen this quite often. We have conventional 2x4 exterior wall construction on a home. The electric panel is located in that same wall, filling the cavity completely, not allowing the minimum R value to be achieved. The panel should be relocated or the wall extended to allow the minimum R value. To follow up on this, we've also seen these panels located on the warm air side of the house, but yet common to a garage. Now, what we have then is we have cold air on the garage side, we have warm air on the interior side, and condensate can occur, and this is something I have witnessed firsthand. So consideration of where the panel is going to be located in the home is very important. Your final electrical residential inspection will fail if you do not have these protective barrier covers over the energized parts at your service entrance equipment. These barriers come with the panels. Now, they quite often get thrown away, but they need to be installed. This first appeared in the 2017 NEC, and it is being enforced more now than ever before in the 2020 NEC and the companion IRC. So this is what's called the intersystem bonding bar. It goes below the main panel on the outside of the house. If it is not installed, you will fail an inspection. Some are exposed, like the one you see in this photo, and others are made with a cover on them. They have to have at least 3 terminal areas where you can connect data and communication lines. I have seen multiple inspections fail, or at least this listed as one of the items for a fail on a residential inspection because this was not installed. When locating a subpanel, we should make consideration as to what the environment is going to be in that room where the panel is going to be located. A good example of this is a panel in a corrosive environment, such as a residential pool house, where chlorine and other harmful chemicals may be stored. I've seen many residential inspections fail because we had a fixed in place double oven and they did not have the protection required by the code. Now, if the breaker is not in sight of the piece of equipment of the fixed in place appliance, then there has to be a hasp installed. It has to be a hasp that's approved by UL and has to meet the requirements of the National Electric Code. I personally feel like whole house surge protection is something that's been a long time coming. If a code did not require this and I built a new home, I would have this installed. With the smart refrigerators and every other appliance we have out there nowadays and all the different things we have with the computers in our homes, I think something like this little investment is money well spent, but it is a code item and there are specific types that have to be installed and they have to be installed per the manufacturer's installation instructions. Arcing primarily occurs at the connection point, the termination point of conductors. As you can see in this photo, we have an arc that's occurring inside this breaker panel. This is a true problem, and it has to do with someone simply not tightening something down. Torquing requirements are now in the residential as well as the National Electric Code, and they should be followed closely, and inspectors should be checking this. Of course, we deal with the real world. Many times I've asked a installer, did you torque all these connections? And they say, yes, I did. And I said, well, where's your torque wrench? And they'll make a big old muscle and they'll be slapping that muscle and saying, there it is right there. This is a very unprofessional way of doing things. You should have the proper equipment, the proper tools, and the knowledge for conducting the type work you're doing, especially electrical, as it is so hazardous when not done properly. There are some that just don't believe that knob and tube wiring is even considered in the code, but it is. It's in the National Electric Code. Now, no new knob and tube wiring can be run, but if you have existing knob and tube in a home, especially a renovation or remodel project, and you're running Romex or NM cable and trying to make a connection to continue a circuit or to feed an area that circuit has to feed, the requirements are that the connection between the NM and the knob and tube occur inside a UL approved junction box. There are specific requirements that each conductor must enter separately into the box with proper connections, and all splices must occur inside the UL box. Also, the loom of the knob and tube must extend at least 1/4 of an inch inside the box. So that concludes this video. We've got a whole host of other videos. Actually, go to the site and look over them. There's quite a few there for you to learn from. Please like, subscribe. We need to go over all this with you as much as we can, and let's try to avoid unnecessary failed inspections on the site, and that saves everybody time and money and a little bit of aggravation.